Couple other simulation websites where we can explore these ideas of the idea of how speed impacts kinetic energy and how mass impacts kinetic energy. So the first one I'm going to show you is the energy skate park. There are a couple versions of it, but I'm going to show you the basics version right now. When it comes up, you should just click on the picture of it in the middle. And then you have some options here. There's the intro, which is like showing you how to work it. Friction, which honestly I haven't explored too much. And then there's playground. We're going to go to the playground one. Now here I have a few things to show you. First of all, this is your skater. Okay, it's automatically set on a middle mass. You can increase his mass or decrease his mass, right? If you also want to play around with friction on the ramp, that button is right below. All right, so we're going to build a ramp first. I'm going to just start with like kind of something basic. I'm just going to start with a U shape. All right, guys, I have no experience with actually skateboarding, so I'm going to imagine this looks fun. I think he's going to like it. I'm going to also try to get these dots kind of evenly spaced. There, I think that looks pretty. Alright, so here's my skater, and I'm just holding him up here, and when he gets close to the track, he just goes on it, and I'm going to let go, and we'll let him go up and down, and up and down. Now, one thing you might notice is that he does kind of lose momentum after a while, and as you may have guessed, that has something to do with the friction. If I put friction down to 0, and I do this again, he's not going to slow down. He's just going to keep going. Keep going. Now, if I increase friction, you can see what happens. All right. Pause that. The next thing I want to show you is there are some pie charts here. Oops. I guess it's not going to let me move it around. The red is showing thermal. The blue is potential, and the green is kinetic. So this is a lot like the roller coaster one where you had those three. So I'm going to move his friction down to, like a normal amount. And I'm going to start him off again. Oops. Come on, dude. And play. Now watch how his kinetic energy gets bigger when he goes faster. His potential keeps switching back and forth as well, and then you can see here that the thermal has kind of taken over. I'm going to turn his friction down to 0, and let's do this again. This time you should see it as a graph that has only kinetic and potential. You can see where it is he has a lot of potential, right there, and right there, and where he has a lot of kinetic, right there. So you can play with that. If you don't like pie chart, you can do a bar graph instead. So that's kind of fun. And you can also track his speed, when he's going the fastest. And if you want a grid to help you out with figuring out the height of this, you can. All right, so this is the energy skate park basics. If you want, at some point, if you want me to show you the more advanced version, I can do that as well. The second simulation is the Catapult lab. Now when you open up to the page, it's going to look like this. Just go ahead and click on Student Lab, and you'll have to click Continue, Continue, get to the screen, scroll down to the bottom, and onto Lab. Alright, so here's our lab. Basically what you get to do is pull objects onto the catapult, choose at which speed you want to send them, and hit the red button. it hits the target and it automatically registers the amount of energy. There's the wrecking ball. Okay, you can see I shot them at the same speed. You can see how the energy might be different there. Okay, and it also shows the mass. So it's kind of a basic lab. Okay, but you do have things that you can change, and it does keep all of your data in a nice spot. Right? So these are two simulations that you can play with. I highly encourage you checking out both just to kind of get used to them.